like we're back. The bottom of the helix, this is Speed. Today's guest is a retired professor who spent more than 40 years teaching computer science at the University of Manitoba. His clinics, of course, relate mostly to computers and software. He's also the incoming Canadian District Director of the NMRA. So welcome to Mr. John Bate.
Thank you very much. This is about 3D modeling. I'm not going to talk about the printers and all that sort of thing. Mike will talk about those in the next hour after this one. What I want to concentrate on in this hour is how do you make a model to print in the first place? And let me just show you a little example of what you can do with that. This is shamelessly stolen from the NMRA magazine, and I encourage you to join the NMRA and get the magazine if you're not already. And somebody wanted to build this particular very strange old locomotive. As you can see, it's got a lot of unusual parts. And so to make those parts, this particular individual did 3D printing. So there's some of the things. There's some more of the things. So printing the whole locomotive in one go, that's not practical, but you can print all of the, the side frames for the trucks and the little bell thing and ends and so on. Here's a long hood that he wanted to put on something. And this was done in SketchUp, which is exactly the program I want to show you. There's a little screenshot showing SketchUp right there. And so this is something that you can do. And I'm going to throw in another little piece of information here. If you do the drawing in SketchUp yourself and then print it, that's scratch building by NMRA rules. So if you do this, that counts as entirely 100% scratch built. But you got to do the drawing yourself. No fair going and printing something that somebody else has done. You have to do it yourself. So I'll show you how to do it yourself, or at least a little bit. You're not going to learn all of this stuff in one go. That would be just about impossible to do. But I will at least show you the basics of it. Okay, so here is how to get started. You want the SketchUp program. You can go to SketchUp.com and download their, well, not even download, use their buttons that say, try the free version here. Their newest versions are all web-based. In other words, you do not install anything on your computer. You just use them on a browser. And I find that a little clumsy and awkward and slow. Personally, I would rather have the software installed on my computer. And so the one I'm going to show you is the older version. And if you want to get that one, Google SketchUp Make 2017. I've got it highlighted right there. Google that and ignore the SketchUp.com link at the very top. Go to the one that says downloading older versions, like at the top of this window right here. And that'll take you to a page that they don't even want you to see anymore. It's on their website, but I don't think they have a single link to it anywhere. You're never going to find it unless you Google it. And you can go down and download SketchUp Make 2017. That's the last one that you could actually run yourself on your own computer. Okay, and it's Windows or Mac. Download it, install it, all the usual stuff. And what you will get if you run it is a screen that looks like that. What you want to do on this one is down in the bottom, there's a little button that says start using SketchUp. There's a lot of other buttons you might get that say use the free version here. Don't touch those. Those take you back to the website and the online one. Use the little start using SketchUp button down in the corner. And if you do, you'll get something that looks like that. Now, I'm just going to change my screen sharing just a little bit here. And just show you that window. Okay, most of the rest of the time I'll be spending just showing you how to do things in this window. First thing you want to do is, this guy is giving you an indication of scale. He's 6 feet tall. So we're working in prototypical scale units here, not model, millimeters or something. But click on him and hit the delete button on your keyboard because we don't really want him around. Okay, there's a blank screen. Now, I'm going to spend a fair bit of time talking about the basics of things. and the fundamentals. Most of these tutorials, and there are a lot of them out there on YouTube. SketchUp themselves has a whole bunch of tutorials you can see, which are excellent, but they mostly show you the fancy stuff right off the hop. And when things go wrong, you don't understand what's happening because you don't understand the fundamentals. So I always want to start with the fundamentals. So here's some fundamentals for you. First of all, you're looking at a three-dimensional space, but on a two-dimensional screen, which really requires a little bit of, visualization. So there's three axes: the red one, the green one, the blue one. Think of them as red going side to side, green going back towards the horizon, and blue is the one that goes up and down. Remember those directions because you will need to use them when you're drawing something. Okay, I'll show you a bunch of the tools, which are these things right along the top. And most people start with the fancy ones, but I'm going to start with the pencil, which is the line tool. You can get that by hitting the L key on your keyboard as well. And with this, you can draw a line. Now, second big fundamental thing in SketchUp is you don't drag, no dragging. To make a line, you will click in one place, like the origin there, and move the mouse someplace. Now, my hands are not on the mouse at all here. You're not dragging, you're not holding the mouse button down. I just clicked in that one spot. You move someplace else, and you click someplace else, and you get a line there. Okay, I'm going to go and make another line. Now, the other thing you can do is, I'm not holding my finger on the mouse button here, I'm not dragging. The other thing you can do is type the exact length that you want, or the exact shape that you want when we get to more complex things. Down here in the corner, which you can hopefully see where the cursor is hovering around, there's a length, and it says 8 feet 4 7/8 inches right now. You can just say, I want a line that goes straight up exactly 4 feet. So I would just type 4 feet on the keyboard, of course, and hit enter. That line is exactly 4 feet long, very, very precise. Okay, so that's the reason you do a click and then another click, is you got to take your hands off the mouse to type things in. All right, so no dragging. Click, move it, do a second click, or type how big you want the thing to be. Next fundamental. When you draw lines that form a closed loop, so lines that go back to where they started and they're in the same flat plane as these are here, you get what's called a face. So there's a face. All right. The whole idea here is to use these faces, think of them as infinitely thin pieces of styrene or something, and you're going to use these faces not to make an object, but to make a mold for an object. You have to think you're making a mold here. That's a very important thing to keep in mind. Okay, one important thing about faces, which is also a fundamental that they kind of skimp on a lot, is that there's a front side and a back side. So this is the front side of that face, and that's the back side of that face. Can you tell the difference? Well, the back side, if you're looking straight onto it, is a light gray, whereas the front side, if you're looking straight onto it, is white. But you spend a lot of time looking at faces at an angle, and they're all gray. How do you tell the difference? Well, what you really want to do is say, no, you stupid program, don't make them all gray. I'll show you a trick to make the back sides a bright color, red or yellow or something. Over on the side here are a bunch of fancy stuff. They're in this thing called the default tray. If you close it or lose it for some reason or other, you can always go and say, show it again right there. So I'm going to show it again. Inside here, there's all sorts of things. There's materials and components and styles and so on. Under the styles one, there's an edit. Under the edit, there's the back color, the front color and the back color of faces. Say, no, you silly machine. I want red. Thank you very much. And, make the back sides red. Okay, now, see, now I can tell that that's the back side and that's the front side. Most people don't even tell you about this, which is really unfortunate. Okay, so there's a face. You can't print that. That's not a three-dimensional model yet. But let's turn it into a three-dimensional model. Let me do it by just drawing lines. Theoretically, you can actually build anything you want by just drawing lines. So there I've created something that looks like that. I'll tell you how to move around in a second, like I'm doing here. You're going to want to spend a lot of time moving around because you really can't visualize, see, like that. You can't tell what shape that is on a two-dimensional screen. It's a three-dimensional thing. But as soon as you start moving around, your brain is very, very good at saying, oh, okay, I know what that is. All right. And so I got another face down here. Let me just go to the little arrow. The little arrow is, of course, something that allows you to select things. So you can select a line and it turns blue. Hopefully you can see that blue line there. You can select a face, sort of gets kind of mottled. Here's the other face. And by double clicking, sometimes you want to select a face and its lines that form it. A face is always formed by lines that go around it. So there's a face and its lines. If you triple click, you'll get everything. All the faces, all the lines, the whole shoot and match. Sometimes you want to do that too. So here's two faces. Let me draw one more line. And there. And now I've created a solid. Now I haven't created a solid, I've created a sort of a mold. That you can 3D print. You can go and tell your favorite 3D printer, okay, print this thing, and you'll get this shape printing out. Now, it's very important that the outside be the front of the faces, and the inside be the backs of the faces. Let me delete this face. You can select anything and just hit the delete key to delete it, which is fairly self-explanatory. Notice the inside is red. The outside is blue. That's how it tells what to print. It will print towards the red sides of all the faces and not towards the white sides. So here, it'll print the insides of it. If you screw up, let me do something here. Let me select the whole darn thing. And if you right click, you get a whole bunch of contextual pop-up menu things, as almost every program in the universe does. And one of the things that's in here is reverse faces. I'm going to turn them all backwards. And if you happened to create something and you got something that looked like that, what that would actually tell a printer is print the entire universe except what's in that box. You're not going to do that very easily. That's just not going to work. When you go to print something, it's very important. I'm going to select it all and reverse it back again. Very important that everything be white. Don't see any red, okay? Assuming that you've done the trick to make the darn thing red. Sometimes you might just get one face that's backwards. You can't print that either because it can't figure out, well, wait a minute. You want to print this side of that one, but that side of this one, and it doesn't know what to do. That's unprintable. You can't print that. There are ways of fixing it. I'll show you some ways of fixing it, but you can't print that thing. So lines can create faces. Faces are what you need. In fact, it's all that you need. What I'm just showing you, you could theoretically make the most complicated model going with just those tools and just what I've showed you. It wouldn't be easy. It would be a real pain in the neck, but you could theoretically do it. Okay, so there is some of the basics. Selecting things, the axes, the red, green, blue axes, the line tool, making a face, and so on. Okay, let me show you now. Let me just blow all that away and start from, whoa, not that fast. Okay, and start from scratch here. I'm going to make a rectangle, and I'm going to start building a building here. So I'm going to make it, I want a 20 by 25 foot outside shell of my little building. Maybe it's a yard office or something. So let me introduce you to the rectangle tool. It's this one right here, or click R for rectangle. And once again, you can click someplace and then just start moving, but don't worry about getting the whole thing. Just type in the dimensions. Again, down in the bottom, it's showing you your current dimensions. I want 25 feet by 20 feet. So I just type 25, quote, comma, 20, quote, enter, bingo. Now it's a little big, so I'll go out a little bit. And there I've created a 20 by 25 foot floor plate for my building. Now for the tool that they almost always show you right at the start, which is this one. It's the push-pull tool, and it's how you take any two-dimensional thing and make it three-dimensional, which is really the starting point for all of this. With the push-pull tool, you always have to take a face, and I want to click on this one. Again, no dragging. I just clicked on it, and just move up. And you can extend or extrude a face at right angles to that face, however much you want. I want to go exactly 8 feet 6 inches. So I want to type in 8 feet 6 inches. And there's my building with exactly the size that I want, the perfect right angles at all the corners. You print that thing, it'll be way better than probably you could ever do with a piece of styrene. And there's the starting point of my building. So the push-pull tool is the way that you create things that are three-dimensional. And it will automatically make the insides red and the outsides white when you do that. So that's nice until something goes wrong, and then maybe that's not so good. Now, let me show you about all of this moving around stuff that I've been doing. A fundamental tool is this orbit tool, which will allow you to, move your eye, your camera around and look at things from all angles. This is the, I don't even know what they call that thing. It allows you to move something straight up, down, sideways. It's not orbiting. You're not going around the thing. You're just putting it in a better position on the screen. And there's the magnifying glass to let you zoom in and zoom out. Nobody actually uses those, okay? The real thing you want to do is have a mouse with a clickable scroll wheel. And then while you're busy working on your model, all you have to do is press that middle mouse button. Presto, you get the zoom thing. Not the zoom thing, the orbit thing right away, and let go. Suppose I was in the middle of drawing a line. I'm drawing a line from here, and I decide, oh, wait a minute, I want to look at it from over here. Okay, so I do that, I let go, I'm still drawing the line. I haven't left what I was doing. You can orbit things while you're working, which is really almost essential. Likewise, if you go to your middle mouse wheel and click on it to get an orbit, hold the shift key down and you get a pan instead. That's what it's called, pan. And you can move it up like this. And of course, if you scroll the scroll wheel, you zoom in and zoom out. It'll zoom towards exactly whatever spot you're on. So if I want to see that corner over there, I can zoom in on that corner, or maybe this corner or something like that. You get rid of that line. So that's how you zoom around, and you spend a lot of time, do this lots. Every time you do something, look around, see what it's looking like, see if it looks correct. Okay, so there's a starting point for my building right there. But if I printed that, what does my mold look like? My mold looks like a solid box. You're going to get a imagine an HO building or something that is a solid block of plastic. I don't think you want that. You want, thin walls. You don't want a solid block of plastic. You're going to be charged if you print this thing either from your own pocket or to Shapeways or something by the quantity of plastic or material you use. No, I don't want that. I want this thing to be hollow. Well, let's look at the bottom of it and say, I want to make most of this bottom go away. How would I change this face? Let me show you yet another tool. And please, by the way, you can type a question or two on the fly here. That would be fine as long as we don't slow things down too much. This tool there, the offset tool, this will allow you to take a face and make another face exactly the shape of that one, but a little bigger or a little smaller. So I'm going to say, I want this one to be, in here or out there. Whatever shape, no matter how complicated it is of that face, you'll get a bigger or smaller copy of it. So I want to move it in a little bit. I want 6-inch thick walls. So again, type it. I strongly suggest, rather than free-forming anything, type in prototypical coordinates of whatever you're trying to do. Keep it accurate. Otherwise, things might go a little funny from time to time. Okay, so now I've got this face and this one. I've got a sort of an outer rim face, that's one face. It's rather a complicated face. And this one, well, that push-pull tool is not just called the pull tool. It's called the push-pull tool for a reason. I can take this face and I can push it just as well as I can pull it out. I can push it back. And here's where the measurements come in. I know that wall is 8.5 feet, so I'm going to push it back only 8 feet. And now I should have a nice hollow box with 6-inch thick scale walls all around. Once again, I like to do this, remove one side of my mold so I can look inside, just delete it, and then look inside and then put it back. And so you can see, look down the edges there, you can see the 6-inch thick ceiling and the 6-inch thick walls, and you can see how this mold looks. Remember, you're building a mold, not an object, okay? So I've got, when I print this, I don't have like double walls or anything. I just have 6-inch thick pieces of material. Okay, undo is Control Z or Command Z, of course, as it always is, to put something back after you've taken a quick peek inside. Okay, so there's a basic thing for a house. So we're seeing lots of tools here very quickly. Now, of course, you're not going to learn how to do this by watching me here, because it's going by very quickly, first of all. And second of all, you've got to actually get your hands on a mouse and the program and try it and do it. And there are, as I said, lots and lots of tutorials online to allow you to do this. But remember the front and back sides, the fact that to make or break a face, it's a line that you need, and so on. The fundamentals of it. Okay, I want a peak roof on my little house here. So how would I get a peak roof on this house? Well, what I might do is say, well, let's draw a line down the middle of the ceiling. Now, notice right there, when you get to the middle point of a line, or many other places of interest, intersections, the origin, whatever, it'll light up and it'll tell you that what you found. There is the exact midpoint. You can always find the exact midpoint of a line. I'm going to click there. And I want to go over to the exact midpoint there of the other side. Okay, now I've got a line exactly down the middle of my building. And let me introduce you to the next tool on the list. I'm almost going through them in order along the top here. The next one is the Move tool. So the Move tool, well, what do you expect? It allows you to move things. So it'll take that line and allow me to move it. Now, where do I want to move it? Do I want to move it like this or like this? I can move it, I can get a very strange roof if I want to. No, I want to move it straight up. Remember, back and forth, red. Towards the horizon, green, up and down, blue. So if I move it so I'm more or less parallel to the blue axis there, it will say, oh, you want to go in the blue direction. There we go, blue axis. I'm going to move it up 3 feet. Type it, 3 feet. So I know exactly that's not very much of a peak on there, but okay, 3 feet. And there we go. Now, look inside. I didn't change that face. Remember, there's two faces to every wall and everything, the inside of the mold and the outside of the mold. I changed one side of the mold, but I didn't change the other side of the mold. Let's peek inside. Oh, okay, so if I say, hey, print this, printer, I'm going to get a solid block of plastic from my attic. Oh, no, I don't want that. Well, while I'm looking inside, why don't I just do the same trick on this face right here? So see, this face here is the other side of the mold for my ceiling or roof or attic. I'll just do the same thing here. I'll draw a line from, there's the center point, over to the center point over here. Where is it? There. And there I've got a line, and I'll take that line and use the Move tool to move it up. Make sure it says on the blue axis. Same amount as I did the other one, so 3 feet. In order to get them parallel, you have to know how far up to move it. So if you know exactly the measurement that you did last time, you can do it again. There we go. Now that's better. Now my mold looks a little better. Look at it from underneath. Yeah, there we go. That's more like it. Now, I can't use undo to put that face back that I used to peek inside. How do I put it back? You would be amazed how hard it is to find that information with a Google search or from SketchUp or whatever. But if you know the fundamentals, it's really simple. Oh, just draw a line from anywhere to anywhere on the edges of that face. There you go. Because I now have a whole bunch of lines that enclose this area, and it will always automatically make a face whenever you do that. Likewise, I have a whole bunch of lines over here that are enclosing that piece of this plane, and so it'll automatically do a face there. Now I've got two faces instead of one here. I'm two-faced, I guess. You can always delete the line right away. When you delete a line and it's where two faces join and they're in the same flat surface, it will what's called heal them and make one out of two. Bingo, back again. So remember that trick. It took me a long time to figure out that trick before I realized what the fundamentals of this program were. So there, I hopefully saved you a lot of time in putting a face back where you need it. So there's a little house. Let's do just a couple more things, and then I'll show you how you would actually get this thing printed. How about we make a doorway? Suppose I have a scale, well, 3 foot wide by 6'8" high. That's a fairly standard size for a door. How would I make a door here? Well, how about we draw where the base of the door is, say about there. And I want to draw a little rectangle there. And I want to make it, 3 feet by 6 feet 8 inches. Just type it in. And whoops, wrong way around. Okay, well, try that again. Only hit the right thing. I think I was hitting the ceiling up there is what I was doing. Okay, so oops, I didn't get it the right size there. Now let's do it right. Okay, that's on the edge there. And that's on the edge there. Good. Okay, 3 feet, 6 feet, 8 inches. Oh, it's putting it in the wrong direction again. See, there's the trouble with 3 dimensions is on a 2-dimensional screen, is it can't necessarily always tell exactly what you're intending to do. Okay, well, I wasted enough time on let's just draw it on the dimensions there. Okay, and guess what? Yeah, how about my little push-pull tool? How about I push that up? 6 feet, 8 inches. Oh, I was trying to make it 6'8" wide. There we go. All right, there we go. There's a door, or at least a hole for, pasting in your favorite door from your parts box or whatever. You can also make a very realistic door by doing all of the little slats and things yourself if you want to as well. But the push-pull tool will do an awful lot for you. But not everything. Let's just say I want to make a chimney up there. So let's do it a couple of ways, the right way and the wrong way. It's always more fun to start with the wrong way. So suppose I thought to myself, oh, hey, well, I just need to draw a rectangle, come on, there, on the face. Come on, there. And like that, and then use the push-pull tool to pull it up. I don't think that's what I was going for. Remember, it'll only do something exactly at right angles to wherever that face was to begin with. And no, I don't really want to do that. So you might scratch your head and scratch your head and scratch your head and figure out, well, if I can use the push-pull tool, that's all of the tutorials always tell me about. Well, what do I do? No. Go back to basics. You need a bunch of lines around the edge of where you want your chimney. All right, so draw a line down the roof. Now, here's another little thing. It might put that line, out in space like this. See, that's on the green axis. That's going straight out. It's not following the roof line. There's a thing called inferencing that you can use. If you sort of hover on some other thing like an edge here, it knows now that you're interested in that edge. And when you go back to drawing your line, it'll say, oh, you want another line parallel to that edge. So inferencing is a thing that you can often use to make sure things are in the direction you want. So I'm just going to draw a line there. And then I'm going to go straight up. And then I'll go over. And notice when you actually get something to line up with something else, it'll actually show you a little dotted blue line there saying, hey, you're above that other point. That might be where you want to be. Yeah, actually it is. Okay, I can create a face there. Okay, now that's not printable, okay, because that's not an enclosed space. It's a, thing in the middle of nowhere, all right? But now if I pull that across, and I'm not doing any particular size here, there we go. We can create a little thing there. So go back to drawing lines. I draw this, and then if I extend perpendicular, that'll give me what I want. Don't start with this face. Let's just show you what happens. I think I've got a quick amount of time here. If you started by saying, okay, I want to go straight up, and then along the roof line here, and then straight down, and create a face there, and then pull that one, well, what you're going to get is something that looks like that. Whoops. That just got away from me a little bit there. Yeah, that's probably not what I want either. The other face was the one to use, because if you extend it in a perpendicular direction, it's what you want. It gives you the shape you want. So when in doubt, go back to drawing lines. You can always do anything by drawing a line. Okay, so there's a house. Now, that's printable, but there are a couple of things that might be a little bit wrong with your models. And let me show you a few things about that. The first thing is, you remember, this is a mold. So it's got to be what's known as, quote, watertight, unquote. If that face were to be missing, you can't print that, because all of the, let's call it plastic, will just leak out. It's not an enclosed space. No good. Can't do that. Even if, maybe, for some reason or other, you just had a little tiny piece up here that was missing. I mean, it's hard to see that little red bit maybe when you've got a complicated model. No, you can't print that because it's got a hole in it. It's not watertight. It won't be printable. You'll have to fix that. Another reason that something might not be printable is if you've got just, let's say, a line sticking out in the middle of nowhere. You can't print that, because, well, what's this line doing here? Now, a lot of printers and software will accept that anyway and just ignore it, but technically that's not printable. Or you might even have a surface like that. It's not going to try and print an awning or something. That's an infinitely thin boundary there. And, I can see red. If you can see red, you can't print it. No, you can't have any stray things around. So that's not going to work. Whoops. I'm just going to double click on that. Oh, and usual sort of thing, holding down the control will allow you to deselect or select individual pieces of, come on. It's going to be obstinate at me. I'll just delete them one at a time. Okay, so that's something, several things that can cause it not to be printable. Another thing which is very subtle here, and that is, I actually don't have one surface in there, one way in there. Look up at the ceiling. Shouldn't I be able to see up into my chimney there? I can't. Oh, well, that's because of the way I did it. There's a face here. So I've got one little box for my chimney and another big box for my house, but they're not connected. I really should get rid of that. Now it's one continuous mold. Now the plastic can flow from the house part of the mold into the chimney part of the mold. I don't have two individual pieces. Okay, so let me put that back. Most of the time this will be accepted anyway, but that's technically a reason not to. You want one continuous, no red showing, no spare lines and planes lying around anywhere, box that is all connected inside. Now, there is a tool, and I'll show you how to get it later, that is really helpful for this, and that's the solid inspector. There, I've highlighted in there. If you go and install it, and this is an optional extra, this is an add-on for SketchUp, but if you go and get that thing, it will tell you what's wrong. So it'll say, oops, you got some extra faces. Internal faces, which is what it's complaining about there, are the ones like I just showed you. Okay. I could click on it and it would show it, it would highlight it in red, but since it's inside, you can't see it. A lot of things it can actually fix for you. So if I type in fix, it will now say, everything is shiny. Extra marks if you can tell what TV program that's from. Maybe type it into the chat. I'm pretty sure a lot of people know. And if we look inside, we'll see that it actually has fixed that up. It did the deletion of that for us. So a lot of things it'll fix for you, and it'll certainly tell you all of the things that are wrong. All of those things that I just showed you, it'll highlight all of them and say, hey, that's wrong. Sometimes it can't fix it. Like, for example, if I reverse this and go and say, inspect that, it'll say reverse faces. Oh no, what's it going to do? Oh, it did it right. So often it won't do that one right. Often it will screw up on that one. So it's not perfect, but it will highlight that. Use that often as you're going. Every time you do a step and add another thing, use that to inspect it. And then you know where the problem lies if a problem shows up. Okay, we better move on to how you get this printed. Okay, so suppose that's all I want to do. Suppose I want to print that. How do you go and get that printed? If you have your own printer, well, it's one thing, but I'll show you how to get it printed by a commercial place, Shapeways. First thing you want to do is, this thing is 25 feet by 20. You don't want to print that. I think I want an HO one. So triple click, get the whole thing, and one more tool right here. This is the scale tool. So I want to scale this down. Grab a corner, not a side, or it'll distort it. And say, click, again, no dragging, click. And down in the bottom corner where all these dimensions always are, it says 0.34. So I've got about a 1/3 size. I don't want 1/3 size. HO scale happens to be 0.011 something, something, something. That's close enough. And there's my HO one. If I zoom way in on that, there it is. Only this is the HO scale version, which is a little more printable than the full scale version. One more tool. Here's a measuring tape. You can click on that and just go from point to point, and it'll tell you that's about 3 5/16 inches, it says. Check it, make sure it looks about right. If that said, 18 feet, you're in trouble. Okay, so I want to print that thing. So it's in HO scale. Save it away. Now, the next thing that you need is you need an extension. So at this point, let me show you how to get extensions. There's a thing called an extension warehouse. And these are things that are largely supplied by individuals, not by the company. And the extension warehouse has many, 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 many things in it. I'm going to go to the categories, look at all these things: energy analysis, landscape architecture, woodworking. I use this program to design my an arbor in my backyard and a fence. It was actually originally intended as an architectural 3D drawing. But under 3D printing, you will find a couple of things. There's the first one, SketchUp STL. You need that to create an STL file of your masterful design here. STL files are what all printers speak, and things like Shapeways. And then a little further down is that solid inspector thing that I just showed you. Go get them, install them. I think it asks you to create a free account. Everything asks you to create a free account and put them in, which I've already done. So up here, we're going to go to Export STL. These things show up in different places. This one shows up under the File menu. And I'm going to export STL. I have problems with dual resolution screens here, so it will look a lot better for you. The only important thing here is select a unit and remember what you selected, because you have to select the same thing when you go to print it. It doesn't matter what the units are, but you have to be consistent. So I'm just going to leave it as inches, and I hit the export button, and I will export onto the desktop so I can actually find it again. A NMRAx demo. Okay, and there you go. Now you've got a file that can be printed. And at this point, we're done with SketchUp, and I'll switch over and show you something else. Guess it's that one. Okay. No, it's not that one. Wrong one. Let me get the right one here. That's photos, that's SketchUp. Okay, so again, you have to have an account, you have to log on. So all I do to print that thing is go and say, upload a 3D model right here. I'm logged in. And when I upload a 3D model, it'll say, okay, choose your file. So I just choose a file or drag it there. There's the NMRAx demo. And now it will upload that file and it will do a lot of those checks that I just did using the extension. So it's going to, subject your model to the fine tooth comb here. And that's okay. Oh, and I hope I got did I get the dimensions right? I think oh no, it's in millimeters. Oh, well. I probably want to do that different because notice it's not 3.3 inches, it's 3.3 millimeters. It's rather tiny. Perhaps I would rather do it with the right thing. Okay, units. Let me do that again. Select the units first. It doesn't matter which one, but just make them the same as what you saved it. Upload that thing again in inches this time. Correct my error. All right, and so it'll upload that. It'll analyze it. It'll make sure that it's a printable thing. I wonder if it's going to complain because it has the same name as the other one. It just might. Oh well, if it doesn't react soon, I'll have to go over here and go back. Oh, here's an HO scale one. Okay, this is another one. Let's just say I want to print that one. So here's one that's it's almost the same as the one I just did. This is from a previous demo, and it'll show you what volume it is, how much support structure it needs to print it, how much space it needs in the machine, because these guys cram the machine absolutely full. And the more of their machine you take up, the more they're going to charge you. The part count down at the bottom, make sure that's only one. If it's not one, if it's 2 or 3 or 4, you've got a bunch of disconnected pieces, as like I had with my chimney there at one point. Make sure that says 1. And here's the sort of cost. Versatile plastic will do for, most larger sorts of models. For fine N scale stuff, which I'm in N scale, I'll go to the fine detail plastic. Now you can see the cost is rather large to print an HO building in that fine detail stuff. But if I shrank this down to N scale, that would be about $30 for N scale, because N scale is 1/8 the volume, the plastic of an HO scale. And if you're an O scale, well, got a bank loan. Notice you can get it, printed in steel or aluminum. They've taken gold off the list, or maybe it's only if the thing is small enough. But a gold version of this would, I think I saw $20,000 or something like that. I think most of us can't afford it. So you can pick your material. Let's go with a versatile plastic. You will often get some options, like, if I want to print a pink one. That sure doesn't look pink on my screen, but okay. And different finishes. I think the white one had, it had a choice of finishes. They can smooth it out and make it a very smooth finish. So you go and select your options, and then it's the usual add to cart thing, and get out your credit card, and away you go. And about a week or 2 later, you'll get in the mail a printed object. And away you go, building your locomotive or your building or whatever. A whole building is not really all that practical a thing to do. Pieces of it may well be, like the stuff I showed you at the very beginning. Probably not, entire buildings in larger scales. But there's how you would do it. There's how the whole thing would work from start to finish, from getting the software to using it, the fundamentals of it, how to get it printed. And Mike is going to come on in a few minutes and talk about, well, how to print it on your own printer, mostly, and he'll talk about other things too, I'm sure. So at that point, I think I will just stop sharing that and go back to the screen and see if there are any questions.
Of course there are questions, like any other new technology. So, first one was when you created the walls, someone wants to know how thin can you make those walls, or how thin should you make those walls?
It depends on how you print it. Those different materials that I showed you, they will each have something buried in there where you can find specifications on it. So that fine detail plastic, you can get very, very thin with that. Suffice it to say that you can get quite thin, but if you go too thin, it becomes not very structural. It will your building won't stand up very well. So in that little particular building there, a 6-inch scale HO wall was way thicker than it really needed to be. But when I shrank it down to N scale, I wouldn't want to go much thinner than that. Yeah, basically check the materials, because they all have different properties.
So someone asked if this tool can scale things, and if you need to enter the measurements in inches or millimeters.
You can choose to work when you're building the object in whatever you want, meters, feet and inches, millimeters, whatever. You can work directly in modeling size coordinates, or you can work in prototypical scale size coordinates. Since most of us are building parts for a locomotive or a car or a building or something, it's nicer to work with those sorts of measurements, and then afterwards shrink it down by 1/87th or 1/160th or 1/48th or whatever your favorite number is, and turn it into your scale model at the end. So within the last clinic I did this thing for, I scaled the same building that I just did down to, I did an HO1 and an N1 and printed each of them separately. So you can scale it by whatever you want. You might have to do the math. The math consists of taking 1 divided by 87. It's not very big.
Do you send all your printing to Shapeways, or do you have a local printer?
I'm in Canada, and there's Shapeways, there's Sculpteo. Sculpteo, unfortunately, their cross-border shipping is absurdly, ridiculously high. So Shapeways, it actually ships to Canada relatively cheaply by comparison to the other ones. So I use Shapeways not for any other reason, but just because I can get it.
Okay, so how long does it typically take?
Not that long, couple of weeks maybe. It depends on how full their machines are at any given time. They have a big queue of things waiting to go into their machines, so it's more of how busy they are.
Okay. And can you do curved shapes?
Sure. Yeah. I could, while I'm talking, I'll just fire it up in the background here.
Which leads to the next question. Can you make people with this software?
Well, people are extremely complicated shapes, so you can make a rough approximation of a person, or if you're lucky enough to have some sort of a 3D scanner where you can scan a person in and get an actual mesh, it's called, of dots on a person, you could do it that way. I wouldn't want to go into trying to make a person myself, because that would just be too complicated.
I always answer that question with, how small a circular cell do you want to start with?
If I can share my screen again. Yeah, no, go away. So yeah, what happens if you draw let's say a circle, and I can just maybe pull that up and make a cylinder out of it. So, there you can see a nice curved shape. Mm-hmm. It's not really a curved shape, though. If you look at it very, very closely, you'll see that what it really is 24 lines. So this is circle that's actually approximated by 24 line segments. If you want it smoother than that, you can increase that number, and you can say, no, give me 48 or 96 or some other number, and make it finer and finer and finer. But you'll get just more and more and more and more and more surfaces. And actually, all the surfaces, when they go off to the printer, are converted to triangles. Everything is in triangles all the time. And so, there's an awful lot of, I just did that very, very quickly. But there are an awful lot of triangles in there.
Yes.
But yes, you can do that. You can even take, let's go up here and just do a freehand thing. So I could even, oh boy, that's ugly. I could even do that. If I wanted that shape, okay, sure enough, there you are. So yeah, you can do things like that.
So when you try to put the dimensions in for the doorway, could you enter those as XYZ to avoid the problem?
No, because all I was at that point, I wasn't drawing anything three-dimensional. In fact, you're never drawing anything three-dimensional. You're always drawing a two-dimensional rectangle or circle or weird shape like I just did there, and then extruding it, but that's only in one dimension as well. You're never directly working with 3 dimensions all at once. It's always one or two at a time.
So the drawing cannot be fully parametric where you type in all the numbers.
No, but you can, of course, the parameter can be your scale size at the end, right? You can scale it to whatever you want, or scale pieces of it while you're going, draw something at this size and then scale it. So not any kind of parameterization, though, no.
Okay. Do you know if you can turn something like your chimney on and off if you want to print another building without a chimney, or do you need to delete the chimney and save?
You can make groups and components, they call them, of things. So you can make a little structure. Let me show you something else, and then say, okay, something of this complicated shape, that's one unit, and then now you can just plunk in those units anywhere you want. Let me show you a little bit more complicated thing. So that building that I showed you, the starting point of, here's a more finished version of the thing. So you can go in and you can create siding with a little triangular sort of.
The very next question was, how about texture and shingles? And I think you have
no. Well, and you could print them on a regular printer, a paper printer, but that's all they are, is they're for looks. A 3D printer would just ignore that. If you want color, texture, anything on a 3D printed model, get out your paints or your standard techniques and do it that way. You can, to some extent. So let me just go up here. I put sort of a texture on my bricks here by making mortar lines that I can easily fill with a black wash or a white wash or something, but it'll all come out as the same plastic color.
Okay. But you can put the texture in if you spend the time.
Yeah, you can. Coarse texture, like the shape of a shingle here, for example, but not, I couldn't put little dots on the shingles to make it sort of mottled or textured, not unless you're working on a very, very large scale.
Okay. Someone asked, I don't know if you said, if
do them piece by piece, that would take up far less space. You could make it very compact. If you want to make multiple copies of something, like there's things that you can get, there's libraries of things that people have designed. You can go and print other people's libraries here. And if you can get a set of, 3 signals or 4 n-scale signals. And what you do is the same as what happens with kits, is they're connected by a sprue. You make a sprue to connect them all together, and you print that so that it's all one piece. Okay. So you can do things like that. But yeah, making sort of your own kit of parts is certainly cheaper.
And then the last question, why do you like SketchUp over the others like Tinkercad or Fusion 360?
Yeah, mostly because this is the one that I've been using for a long time. It's still very common. It's free. And free is always good, Yes. I'm cheap. There are much more elaborate programs. And in fact, this one is not primarily intended as a 3-dimensional drawing program. for making things for 3D printing. That's not what its original intended audience was, which means it does have some drawbacks. So I think Mike's going to talk about some other options, which are more pure 3D things, as opposed to this one.
Well, on that note, John, thank you very, very much for your time.
You're very, very welcome. Hope everybody enjoyed it. I'll pop over to Facebook if anybody has any other questions they want to type in.
Thank you very much. Stay safe.